And last but not least, number 73. Consider the circuit shown here. The EMF source has a negligible internal resistance. The resistors have resistances R1 is 6 ohms, R2 is 4 ohms. The capacitor has capacitance 9 microfarads. And when the capacitor is fully charged, the magnitude of the charge on its plates is Q equals 36 microcoulombs. Calculate the EMF. Okay, so this is a fun problem. So it tells us that the capacitor is completely charged. Completely charged. Which means this capacitor is no longer accepting new charge. So it is acting as a roadblock. No current can go through here. Alright, now, so on our capacitor, because it's fully charged, it has a potential difference across those plates, which we can find like we did in chapter 24, Q equals CV. So the potential difference across our capacitor is Q over C, 36 microcoulombs divided by 9 microfarads. My micros cancel and I get 4 volts. So I have 4 volts across my capacitor. Because it's in parallel with this resistor, that means I also have 4 volts across this resistor. So looking at resistor 1, from V equals IR, we know that the voltage across R1 is 4. We know the resistance, so we can find the current through that guy. So I1 equals V over R, which is 4 volts, over R1, which is 6 ohms. So 4 over 6 is 2/3, which is 0.66666666666666666666. Okay, so that's the current through R1. So now we come back to this capacitor is fully charged. It cannot accept any more charge. So it is acting as a roadblock. You cannot pass. This is Gandalf. You shall not pass. So all of the current that comes through R1 is also going through R2, is also going through our little battery. The current's going like this. Swoop, swoop, swoop. Because this is a roadblock, no current is going to go over here because it can't get through. You short? No. You opened it up here. Okay, so that means the current through R2 is also 0.66 amps. So we can find the voltage across 2 from Ohm's law. So we have our 0.6666666666 amps times our 4 ohms which is 2.66666666666666 volts. So we have 2.666666 volts plus 4 volts gets us back to our battery. So looking at our loop, we have EMF. Here, we'll do a loop for practice. We have our EMF minus the voltage across 2, because it gets slurped out by the resistor, minus the voltage across 1, because it gets slurped out by the resistor, is equal to 0. So our EMF is equal to V1 plus V2, which is 4 volts, plus 2.666666666666 volts, which is 6.666666666666 volts. The end.